Welcome to part 3 of this 3-part homework series. And doing a quick quality check of part 2, I realized that I didn't cover everything on time.cpp, so I'll do that now. Notice on line 4 we're including standard exception, and that's new. We haven't dealt with exceptions yet, and I'm going to start showing you how that works now. So notice on line 23 that we throw invalid argument, we pass it a string, and that invalid argument and throw is how we alert the client program that we have a problem, and we need to use standard exception for that. Okay, and then there's one more critical thing that I forgot to tell you, and that was when we break a class up into two files, time.h, we see class time here, and we talk about these three methods, but we haven't really built the code or implemented the code behind these three methods. We did that over here in time.cpp. And how do you connect these two files so that time.cpp's set time relates back to this class time declaration? How do we link these two? And it's done using these characters, which I'll erase. So set time looks like just a typical function that returns a void and takes three arguments. But to connect it back, we put in the class, capital T time, use the scope resolution operator, and that's how we do it. So now these two separate files, the compiler knows are connected. It knows which class the set time belongs to. And you'll notice it also in these other two. On line 28, you see time, and on 38, time, Okay, let's move on to the actual C++ file that makes use of the time object, and this is called the client file because it's a user of the time class. Okay, we include time.h here. We also include standard exception, and IOStream is for our outputting and inputting. We create a local function, display time, that takes two parameters, message and a time object. Message is a reference to a string, constant, so that we tell the compiler, hey, we're not planning on updating this. If somewhere down in the code we try to change the string that's passed in, the compiler will catch that for us and crash, not crash, it will quit the compile and say, you just tried to do something illegal. And time is a reference to time class, and it's also not supposed to be updated. That's the const. So here we output to the display the message that we passed in, which you see here is on line 23 is initial time. On line 25, it's after set time, and on line 34, it is after attempting to set an invalid time. So those three instances are what is passed in and known as message when display time is executing. Second parameter is a reference to a time object. So you see on line 21, we actually instantiate a time object called t. We pass t on each of these calls to display time because that's the object where we're actually storing the time. And then here in line 24, this is when we call set time. We call it with 127 and 6 seconds. And so we display before and after so you can see. And then we're going to send it some bogus parameters. And you saw back in time CPP, we actually do what's called input validation. And so that's what's happening here. Input validation means that we can write a method that accepts, where's my input validation? It's up here in set time. We write a method that accepts these three parameters, but we don't just take what the user gives us. We need to make sure these are sane values. And since we know the time goes from 0 to 23 on the hour, so on and so forth, we're able to test it here. And if we get bogus input, then we can throw an argument. We can throw an exception to tell the user, "Hey, you had a problem, and this is what it was," and that helps them track it down and fix their code. We could try to fix it, but we won't in this particular example. So, in order to use the exception handling facility of C++, we have a couple of new keywords here. We're going to say try, and we're going to put that in curly braces, and we'll try and set the time to these bogus values. We know that we'll throw an invalid argument, and so now we want to catch that invalid argument. So E is an exception object. It's actually a reference to an invalid argument object. And then we are going to output exception, and then we're going to use e.what and print a couple of new lines. So let's give this a shot. I'll go out, I'll compile it. Let me change to my special directory for such things. And there's our three files, time.h, time.cpp. Those two together are the object or the class that we're going to instantiate as an object, and useTime is our client code. So I'll say cl useTime.cpp and time.cpp. Windows is not case sensitive, but I went ahead and used the casing just in case you're doing this on a Mac or a Linux box. Okay, well that looked like it worked. It created OBJ files. Those are the intermediate machine language compiles, and then they get linked together and create an executable. And so I'm going to type useTime, and let's analyze our output. This is the initial time message, and universal time is set to 0. Standard time, it reports it as 12 a.m. After we set the time, we see it's 13:27:06. In standard time, it's 1:27:06 p.m. Now, then we try and catch an exception where hour, minute, and or second was out of range. We actually could have given a better message, but that's the way the book did it for now. And then we say, after attempting to set an invalid date, the universal time is still set to 1:27:06, standard time 1:27:06 p.m. So 13:27 and 1:27. Okay, so that means that when we got the exception, we did not corrupt the time values that were already in the object. Okay? Now, for the final little addendum, why couldn't I compile this the other night? Well, I got tired. I got tired, and I will show you what I did wrong. I'll delete the OBJ and the exe. Okay, remember we had three files, time.h, time.cpp, useTime.cpp. Time.h is included by time.cpp and useTime.cpp. What I did is I compiled only useTime. Now think about this. We have source code in all three of these files. The time.h source code gets included the first time in one of these two files, either time.cpp or useTime. So it's as if we typed it directly into those. So that leaves us with two source code files, useTime.cpp and time.cpp. Well, I can't just compile one of those. I have to compile both of those. And that gets fed to the linker. And so I need to show you. I'm going to do a dir. Well, I just did. Okay, so you notice I deleted the OBJs. Those don't exist. I deleted the exe. Okay, so let's do this wrong. I'm going to say compile useTime.cpp. And here's the big error we got the other night. So it compiled just fine. But then it got passed off to the linker. And the linker said, hey, I've got unresolved external symbols. And it just so happens that the unresolved external symbols, in this case time, set time, and time to standard string, and if we looked hard enough, we'd find time to universal string somewhere right here. And the reason it can't find those is because they never got compiled. Notice we only have obj for use time, but we don't have an obj for time.cpp. Well, let's look inside time.cpp real quick. And there's set time, and there's to universal string, and there's to standard string. But that's source code. The machine doesn't know how to understand that. So what I forgot to do, which is funny, was to include time.cpp as well. These both need to be compiled. And once they are, the linker is able to resolve the code that's in useTimeObj and the code that's in time.obj. It's able to find all of the code and put it together finally into the useTime.exe, which I'll run again for fun and show that it works. Okay, and so this is the end of the 3-part homework video. Hopefully you've watched all 3 of these and learned from my mistake, and you will get 10 points by sending me an email and telling me that you watched the 3 videos, and just give me a sentence about what was in each of the 3 parts in the email, and that will count for your homework credit. All right, thanks very much.